Hi, this is Jim Rush with Trenchless Technology magazine. I'm here in Cleveland, Ohio with Sylvain Boissonneau. We're here on a water rehab job for the city of Cleveland. Sylvain is with Aqua-Pipe, and first of all, Sylvain, could you tell us a little bit about the Aqua-Pipe process, how it works?
Yes, the Aqua-Pipe process is a lining process that we use for the last 10 years in Canada. So we're a CIPP process that we've been using, and we will line this project here in Cleveland. We've been lining for the last couple of weeks, so now we're almost done. It's a 4,200 feet job here.
Okay, can you tell us a little bit about specifically the process? You were telling about the liner system and how that works.
It's a two-jacket liner, a polyester woven liner that we're going to pull in. It's made of polyester. The inner jacket is lined with a PU membrane to make it watertight.
Okay, in this particular job, you mentioned 4,200 feet of 6-inch cast iron. Can you just tell us a little bit about the condition of the pipe and why this job was needed to be done?
Well, this is a typical 40 to 60 years old cast iron pipe, which is badly damaged because we found during the inspection a lot of saddles, repair saddles. So we know that this section had a lot of breaks, so that's the reason the City of Cleveland probably asked terrace construction to fix it, and they choose the CIPP or the Aqua-Pipe process to do it.
Okay. The cured-in-place pipe market has been pretty established on the sewer side. Can you tell us a little bit about how you see that market going in the water market?
Well, we've done so far 1 million feet of CIPP, the Aqua-Pipe installation in Canada and the US, and this market is growing really, really fast. There's a lot of demand for that product. So Aqua-Pipe, Sanexen, decided 10 years ago to go into that market, and it's been a good decision because the market is growing really, really fast right now.
Okay. In this particular project, what kind of prep work do you have to do? I see the bypass set up here, and the excavation pits. Can you just give us a sense for what needs to be done in advance of something like this?
Well, the preparation steps is very important in having a nice or a good CIPP installation. So basically, the contractor before dig out all the pits, install temporary bypass to maintain water availability to the resident, and from there we came in pipe, which was done prior that we arrived. So here they used a scraping system, but any other system can be used, water jetting or chain scraper, whatever. So after the cleaning is done, we inspect the pipe, install plugs into each house services to make sure we don't plug them with resin, and then we're ready to pull the liner. And after the liner has been installed, we will return and reopen service from within with our robot.
Okay. What are some of the hindrances, I guess, to the water market? I mean, it has been a little bit slower than the sewer side. What basically is the difference in why the water market's a little bit slower than the sewer market to catch on?
It's a good question. Basically, economically wise, not all North America is going through a crisis right now. So I guess money is not as available as we would like to. But sewer was developed longer than water for any particular reason. I think it's basically because we had to develop product that would sustain or be suitable for potable water, which took long time to develop. But now we're catching up with that demand, and more and more you'll see product that will be suitable for that demand, which is potable water.
Okay. Any other projects lined up for the States?
We're bidding a few jobs right now. We should expect some answers in a few weeks from now. But yes, there's a lot of jobs that are being bid right now through different licensee that we have here in the States, and we are expecting to do more and more jobs in the near future. Yes.
Okay. What kind of reaction have you had from the utility owners that have done this type of application for relining?
Very good reaction. In fact, most of the time, typical comment we receive is how efficient is this process, how easy it is. It's not disturbing the resident. We're trying to be quiet, low disturbance for the resident, and at the end, the product meets its promises. So, very good reaction, yes, indeed.
Okay, good, thank you. I mean, you can kind of see on this project here, a small road, but it's still open to traffic. You've got the services open to residents. So, have you had much reaction from the residents here as far as the work and how it's impacted them?
Well, yeah, we interact a bit with the resident. Of course, we're in their street for a couple of days, so we had a chance to talk with them. They were quite happy with the fact that we were as low, we were quiet as possible, as much as we can. Make sure that everybody had access to their driveway, help them around. So good reception from them, and that's basically what we try to do anyway in all of our jobs. It's part of our motto to make sure that every time we go on a job site, we take care as much as the customer than the resident on the street. So.
Okay. Well, thank you very much for talking about the project today, and good luck. Jim Rush with Trenchless Technology magazine. I'm here with Alex Margavicius with Cleveland Water. We're here to talk about the Ferncliff Avenue relining job. First of all, Alex, can you tell us a little bit about the background of the project, why that was identified for the renewal?
Well, we do water main renewal in a couple of ways. If a water main is structurally sound on the outside, but has suffered from internal tuberculation, we've historically used the cleaning and lining process where we clean it and then put a cement mortar lining on the inside. But that's not a structural solution. If a water main has an excessive break rate, we look for a different solution that gives us structural integrity. Traditionally, that has involved main replacement, but we were looking for something new, and we were looking for a candidate. We looked for a street that had a high break rate, and we also wanted to go in a street that really wasn't extremely heavily industrial or commercial. A residential area seemed to strike us as a better first candidate to pilot this technology. We were also in the neighborhood doing some other work, so this seemed, Ferncliff Avenue popped up as a good candidate, as a main warranting some structural work.
Okay, as far as the process you selected, can you tell us a little bit about that and what you found favorable about it to go ahead and pilot it?
Well, we've been looking for some time for alternates to simple open trench main replacement. Open trench is extremely painful to residents, to customers out there, to the commuting traffic out there. You've got a 6-foot wide trench, you got dirt everywhere. It's messy, it's inconvenient. We wanted to try and find something else. Water main is a little bit different perhaps than some other underground utilities in that you have service connections up at a 45-degree angle, the corporations protruding into the pipe a little bit. There have been attempts in the past at various liners, but there really hasn't been a good solution that we've seen yet to accommodate all the issues and challenges that come with smaller diameter main renewal. Until this product came along with Sanexen. We invited their representatives to come in, we saw their presentations, and we thought there was good promise to this one, so we decided to go ahead and pilot this street.
Okay, can you tell us a little bit about some of the initial results, what you found so far with observing the pilot?
Well, clearly some of the major advantages that we liked being without the open trench. You go on site now and it is a much cleaner situation out there. There is temporary bypass, but you'd likely get that anywhere with a main replacement project. But you have a hole only every 500 feet. Traffic is much more easy to get in and out. Residents are far less inconvenienced. Street is much cleaner than it otherwise would be. So from that point of view, from those types of logistics, the project has been successful. There's a whole battery of tests that will be performed after the lining is complete. We will be doing hydrostatic testing as such, so those are results that we're still waiting to get. But initial results, we like what we see so far. We have witnessed the liner going in. It appears to be going in well. Process seems to be well tested. apparently it's a process that they have been used a lot in Canada so far.
Okay. How did the whole process come about? I know that as far as the water main lining, trenchless water main lining has been a little bit slower than the sewer side, and just what was the reaction of some of the people with trying some new technology?
I don't think there's been too much resistance here. We have used structural lining. We've used carbon fiber lining, for example, on a large diameter pre-stressed concrete pipe recently. So we're always looking here, I think. The water industry in general, I think, is a little bit more staid and conservative, perhaps somewhat. But you know, one of the barriers has also been the fact that we're delivering potable water. It's got to be drinkable. And not every product that is used, say, on the sewer side is rated for potable purposes as well. So that's another hurdle and perhaps another reason why there haven't been quite as many products coming along on the drinking water side.
Okay. As far as the next steps, you know, assuming the post-testing and everything goes well, I mean, how do you see something like this being used at Cleveland Water going forward?
Well, I think there is some concern a little bit about price. It is a little bit more expensive than water main replacement. Not hugely so, but maybe a 20% or 30% premium, it appears right now. So I think we're going to have to weigh that. I think we have great hope that in the future, as perhaps the technology becomes more used in the U.S., and contractors become more familiar and comfortable with it, that the price will come down and become more cost competitive with straight main replacement. And we perhaps may take the approach of perhaps bidding some jobs with alternates, with straight main replacement and with this technology. And maybe if they can end up competing, they can just win it straight up.
Okay. Well, anything learned from the project so far that you weren't aware of before the pilot started?
Well, you know, the contractor has had a few minor glitches with some hardware and some equipment. I think that's to be expected. Nothing, I mean, any kind of newer technology, there's going to be glitches and problems to work through. Though I think, you know, as big a conclusion as any is surprisingly how trouble-free it has been, I would say. They've basically been able to come in as planned, and the lining has essentially gone in very well. So we like what we see so far.
Okay. Well, thanks a lot. And well, I guess that's it, huh? Yeah. Hi, this is Jim Rush with Trenchless Technology magazine. I'm here with Mike Ginto, with project manager for Terrace Construction out of Cleveland, Ohio. Terrace Construction is the contractor on the Ferncliff Avenue waterline rehabilitation project here in Cleveland. Mike, could you just tell us a little bit about Terrace Construction, what kind of work you do, and how you got involved with that project?
Yeah, we've Terrace Construction's been around for 27 years now. We've been doing waterline cleaning and lining with cement mortar for 17 years. So we do a yearly project with the city of Cleveland, and it was a part of their project was a CIPP pilot project, and it's kind of just a natural progression for us to go there as technology advances.
You were saying a little bit about the similarities between cement mortar lining and cured in place lining. Can you talk a little bit about some of the similarities as you were mentioning, and then maybe some of the differences too?
Yeah, cement mortar is not a structural liner. The CIPP, the Aqua-Pipe we use in this case, is a structural liner. So cement mortar fixes problems with flow and smoothness, but it doesn't give any strength to the main. Similarities, it's the same overall process. You have the temporary water bypass system, and the cleaning's the same process. The only difference is the installation of the liner, which is a relatively simple process.
Okay, and about the Ferncliff project itself, can you give us a little bit of details and of how the installation went, how many feet, and as well as how it went overall?
The project went pretty well overall. It was 2,040 feet of 6-inch cast iron main that they decided to line. Typically they would replace a main like that because it had a bad break history, but they chose to try the CIPP liner.
Okay, and how about from the perspective of Terrace Construction, what you guys felt about the process, and whether or not you see a future for that type of work?
We like the process. It is something we see in the future being very useful, especially under places like railroad tracks or bridges or creeks. It's a good way to rehab a line and add structure to it without having to dig and replace it.
Okay, as far as the City of Cleveland, any feedback from them on the program and what they feel about the process?
I know they were impressed by the process, and I think they will use it in the future. It's just finding the right place for everything.
Okay. All right, thanks, Mike.